Hello class, welcome to our lesson today. We're going to be starting section 10.7 in our next lesson, but there's some information about section 10.7 that we have to make sure is organized and understood before we actually get into that section. So what we're going to talk about today is what are known as measures of center and measures of variation. Some of these you have seen before and know, others of them may take a little bit more time to figure out. Before we get to that though, just a quick warm-up activity dealing with slope and dealing with rate of change. So the first question says find the rate of change of the graph. Remember, slope and rate of change are synonymous. So it's always the change in y over change in x, and this would be the number of miles per number of hours. So if I just go from the first dot at 0, 0, and then go up and over, realize that the units are a little bit different. So this is up 80 and over to the right 2. So it's 80 miles every 2 hours, which simplifies down to 40 miles per hour. If it's 40 miles per hour, then in 5 hours, that should just be a times 5 situation. You could do a cross multiplication idea there too, but it might be easier just to say, oh, it's 5 hours, so times 5 would be 200 miles. For the last question though, let's go ahead and think about how to solve this. So it would be 40 miles in 1 hour, and then I want to go 810 miles in X amount of hours. There's lots of ways you can solve that. Take a moment and see if you can figure out how to find that. It should be either a cross multiplying technique or a multiply from left to right and figure out the relationship between those two. But I hope that students are starting to figure out how to try to set these up, okay, using proportion ideas. Okay, the first thing about measures of variation and center that we need to talk about is what's known as the interquartile range. Now, I'd asked you in your previous homework to find a definition and write down an example or two. Now, you may not have understood what that definition was talking about, so let's go through this. The interquartile range is the difference between the third and the first quartile. The third quartile is denoted Q3. The first quartile is denoted Q1. In order to figure out where those quartiles are, you have to find the median first. Okay, so for this data set, first off, it's ordered least to greatest, so that's a good thing. And then to find the interquartile range, I'm going to find the median. So a lot of students just kind of go from the edge to the middle. If the median is exactly a number like this is the number 8, we basically say that's the median and now ignore it. Now I ignore this 8, now I look at these 3 numbers only. Essentially, the first quartile is the median of the lower half of the data. So if I look at those 3 numbers, I find the middle of that half. And so the middle of that half would be 5. And the middle of the third quartile would do the same thing, and the middle or median of that half of the data is 13. Once I find Q1 and Q3, I subtract them, and I get the interquartile range of 8. Again, this is new for a lot of you. It's going to take a little bit of time to figure that out, but it gives us a starting point in order to solve some of those scenarios. Another piece about measures of variation and center that we need to talk about is what's known as a box plot, also known as a box and whisker plot. Now, a box plot has 5 pieces to it. It's what's known as the 5-number summary. It is the lowest value in the data set, Q1, the median, Q3, and the highest value. And then you graph it, and the reason it's called a box and whisker is the box goes from Q1 to Q3, a line in the middle, or not in the middle of it, but inside the box for the median, and then a whisker, a line to the lowest and highest points of the data set. When you're dealing with box plots or box and whisker plots right now, the issue that we're going to look at is to make sure when we're comparing data in section 10.7 that we know how to interpret what it looks like and what the 5-number summary is based upon the box plot. The third thing that we need to discuss is what's known as the mean absolute deviation, which is denoted MAD, which is probably an appropriate definition and acronym for this situation. Okay, the mean absolute deviation is the average distance, so mean, average, distance, like absolute value, like how far away from 0, same idea, okay, but deviation from the mean. So it's how far away you are from the average, and then you just basically find the average of those things. So let's look at this example. This is the numbers 3, 4, and 8. So the first thing you want to do to find the MAD is find the mean. So I added the 3 up, divided by 3, I get a mean of 5. From there, I have to find the distance from the mean of each data point. So if I look at the number 3, here's the number 3, it's 2 away from 5. So that's where I got this 2. the number 4 is 1 away from 5, and then the number 8 is 3 away in the positive direction, and it's 3 away from 5. Notice I didn't care if it was positive or negative. Think absolute value. I don't care how far away or which direction you go. I just care about how far away you are. So if this is the 5 is the mean, then 3, 4, and 8 are 2, 1, and 3 spots away respectively. Then I find the average of those 3 numbers. So I add those 3 up and then divide by 3 numbers by 3 because there's 3 numbers. And that will give you a mean absolute deviation of 2. Now, this number probably isn't going to make a lot of sense to a lot of you, but what it's really saying is this is the average distance away, okay, or how far spread out the data is, or the measure of variation. We'll use this to compare data sets and compare the MADs and see if one's higher than the other and what that represents in our next lesson. Okay, just to recap and focus a little bit more on the box plot idea. Okay, here's a data set. Okay, it's got 7 numbers, so I find the median. Okay, that's 8. Since it's exactly 8, I ignore 8, and then find the Q1, the lowest 3. I find the middle of that, which is 5. Q3, find the middle of that, which is 13. Then my 5-number summary is 4, 5, 8, 13, 14. Lowest, Q1, median, third quartile, or Q3, and highest. I would probably suggest just put a point at those 5 locations. And then make the box from Q1 to Q3 from 5 to 13 and draw a line inside the box for the number 8, which is the median. I think drawing the 5 dots might make it a little bit easier for you to work with in order to be successful on those questions. The next one is an example of finding the mean absolute deviation, or the MAD. I'm going to add up all the numbers and divide. So there's 7 numbers. I added them all up at 63. Divide by 7 is 9. Then I find the distance away from 9 for every number. So 9 minus 4 is 5, 9 minus 5 is 4, etc., etc. But notice here, once I get to 9 minus 8, it was mean minus the number because these first 4 numbers are less than the average. When I become higher than the average, I just flip-flop that to make sure it's positive. So I do 10 minus 9, 13 minus 9, and 16 minus 9. I add up all of those numbers. So the 5, 4, 2, 1, 1, 4, 7. I add all those up and I divide by 7 because there's 7 numbers. I get 24 over 7, which is about 3.43. Now, when we get into context of situations, it will make more sense what that's telling you. But it's saying the average distance away from the mean is about 3.43. Again, all of these numbers, when we add them together for the MAD, should be positive because it's just the distance away from the mean, not necessarily positive or negative. Okay, the next question is kind of what your homework's going to say. It's going to say, here's a data set, find the mean, find the median, find the mode, find the range, find the IQR, find the MAD, and graph it. Probably the most important thing, and since we've already kind of talked about a lot of these things, so I'm just going to highlight a few things. The most important thing is probably for the median and the IQR and the MAD, you got to order the data. So if you look here, I took the data set and ordered it from least to greatest. To find the mean, let's recap. You would add up all the numbers, divide by the total amount. The median should be the middle number. Now there's 10 numbers here, so the median is in the middle of the 2. Now it happens to be the same because 10 plus 10 divided by 2 is still 10. However, when I find the IQR for the Q1, I need to now include this. If you have to find the average, the median is in the middle of that, so just draw a line there. And now the lower half is these first 5 numbers, and the first quartile is the middle or the median of that, which is 8. The third quartile is the median or the middle of the upper half, which is 14. The mode, there's 3 modes because there's 3 numbers that occur twice. The range is the highest minus lowest, which is 16 minus 7. The IQR would be Q3 minus Q1, so 14 minus 8, which is 6. The MAD is a little bit more complicated because you have to find all these numbers. First off, we already found the mean. Here it is, it's 11. And then I just find how far away each number is from 11. So 11 minus 7, 11 minus 8, 11 minus 8, etc. But then don't forget, once you get to 12, you got to flip-flop. 12 minus 11, 14 minus 11, 16 minus 11, etc. You add up all those numbers and you should get 28. And then you divide by 10 because it's finding the average. So divide by 10 because there's 10 numbers, and that gives you an answer of 2.8. Again, this is a lot of information. When you're doing your homework for these situations, you've got to show work on the MAD. If you don't have work shown for the MAD, it's not going to be counted right. You need to reorder the numbers from least to greatest. You should probably be able to find these pieces, but you've got to show some work. You've got to show Q1, Q3, the median like this. Okay, we need to showcase how to find the IQR. You need to write out all this data like I've kind of written right here. That's what we're looking for. To find the mean, I would encourage you on these questions for your homework. I designed them in a way that they shouldn't be as complicated, which means the numbers should work out decently, at least for the mean. The MAD might have a division that's a little bit annoying, but for the mean, I would encourage you to write out how to find the mean, which is add up all the numbers. Don't just plug it into your calculator. Okay, show the numbers that you're adding together and then dividing by the total. The box plot remembers the lowest number, which is 7, Q1, which is 8, median, which is 10, Q3, or third quartile, which is 14, and the highest number, which is 16. I put a dot at each one of them, and I draw the box from Q1 to Q3 with a line at where the median is. We'll talk more about kind of what this means. Essentially, since this side's a lot larger, this data on this side is more spread out. Just visually, that's what it's showing, but we'll talk more about that in our next lesson. Okay, your homework is these two data sets. Now, please make sure you're showing your work, especially for the mean and the MAD and the IQR. We want to see some work shown here, not just the answers. That's not going to help us to be successful. So make sure you're showing a little bit of work on how to find the mean, how to find the median by ordering the numbers, so you're going to have to do that on your own. I don't think you need a lot of work for the mode, but the range, show how you found the range. How did you find the IQR? How did you find the mean absolute deviation? And then we're looking for a box plot like what we did on this last slide. There's only 2 data sets that you have to look at, but it's going to take a little bit of time to do both of those. And again, work on this as much as you can without your calculator to showcase how you're adding numbers up in order to be successful. I would definitely double check your mean with a calculator to ensure that it's on the right track though. Have a good day, everyone.